Everybody, Sadler here at the Michigan Championship, checking in team number 2767, Stryke Force, one of my favorite teams in first. Talk more about this fantastic robot. I have Peter, Avery, and Jacob, and this team, 2 event wins already under their belt. They've been world champions twice, recently as well too. They've been known for their swerve drives and awesome shooters. I want you to pay attention as we go through this robot. Of course, we'll be talking that full cargo journey, but this team has actually been shooting from the traversal rung, which is super cool. Can't we talk more about that? Coming up here on Behind the Bumpers.
Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register.
So starting out on this spot, let's talk about your drive. Stryke Force has always been known for amazing swerve drives. Just talk to me a little about the customization and why that's so important to your team.
Yeah, so our swerve drive, we have it completely 3D printed. We try to make sure its components are all correct. We have the azimuth and we have the drive. They each have 2 separate motors for all 4 corners. We have an example here of all the printed ones right up the box. These are our spares if needed. We just try to make sure they're all functionally working because this is what really gets us moving around fast with speed and keeping us with the defense too.
I just want to talk, can we open that up real quick? I mean, it looks like to me that these are super easy to swap out on your robot. Can you just talk about that process if you do need to swap one out?
Yeah, so basically we have some pulleys here. We take off the collars and then we take off the pulleys, the timing belts, and then pretty much we just have to take off the bolts and replace it. It just takes an easy slip on. Sure. It takes us probably about 10 minutes for each system, which isn't too much for when we need to do a quick change.
As we start to go into your robot here, talking about your intake, things I like to hear about too is not just what you have, but like how did you come to this point with your intake? Were there any iterations you made throughout your season and anything else that you tried out that maybe didn't work for your team?
So yeah, so first off, we actually only had an interior intake. This component here, which is the exterior intake, was not even in the list of what we wanted. We wanted to start small and then work our way. So we had the interior intake. We found out that Andy Mark had a lot better grip. We used many different like mechanism wheels, but those were the best to get the cargo in as fast as possible. If you can run the exterior intake. So this is the exterior intake. This is what we added actually for Lakeview. So it's been pretty recent. It's been about 3 weeks that we had this. It's just because it's easier to get those balls in there in tight spots, and especially for the wall. When Avery and Tori are driving, they have problems trying to get those in.
You guys might take the award for the quietest intake in all of First, by the way, too. Just super smooth. I know you can't hear us too much on the video, but this is a super smooth process. Can we see a piece of cargo go in and maybe talk about, I know you guys are using color sensors as well, too. Let's talk a little bit more about that.
Yep, for sure. So it should be color sensors for blue right now, so the blue should go in. Yep, and then red should not be, should come right back out. So for the programming, you set that all up. So all it has to do is just bring it in, bring it back out, and we can go ahead and get our proper color for our alliance.
And I know we'll talk a little bit more about some programming later, so I don't want to spell too much on that, but let's continue going through your robot here into your indexing and into your shooter as well.
Yeah, so basically the exterior intake is actually the interior and exterior is all in the same motor with the Falcon, and then it runs through these magazines, which are just rubber belts. Then run on another motor, Falcon motor. That comes up, and then it comes up here and it stops. And then we're ready to move the turret for the motion to shoot the ball.
As we go through this, I think Avery's going to talk a little bit more about your turret itself. So talk to me what's gone into it and how you're using it on the field as well too, Avery.
So during a match, we can shoot anywhere on the field. We can come all the way up to the driver stations, but we can't shoot in the hangar. Sure. Not in between, because that's a little hard for the balls to go up through there.
Yep.
So as we're just going around, we have something called a fast shoot. So as we're just on the field, I will press A as soon as the robot knows we have one ball, and it will shoot out the balls faster, so that's how we get a faster cycle and all those different kinds of things. We also have just an arming process where I just arm it so the turret will turn on. I'll show you that right now. So this is arming. The turret will just turn on and it'll the eyes. Tori will then have to shoot the balls herself. And then for fast shoot, it's the same process, but it actually shoots by itself. And for our turret, we have 365 degrees.
When you're looking at from like a cargo acquisition standpoint on the field, what has Stryke Force done so well in order to just get your cycle times down so quick?
So as operator, I usually do some of the communication, and so does our coach, Corey. So on my controller, I have rumble. So for fast shoot, I have to arm it as soon as the robot knows we have one ball instead of me. So as soon as a ball is picked up and hits a color sensor right up in here, as soon as it breaks that beam, my controller will rumble, and that tells me that I can arm it. And then I'll usually tell Tori we have one, and then we have to go pick up another. And as soon as she stops, it just shoots.
As we keep moving on this robot, I'd like to hand over to Jacob, who's going to talk a little bit more about some of the programming, and then we'll talk about some of your climb as well, too.
Okay, so for climb, we have these two beam brakes down here, and when these come up, these extend. Let's extend them. We're gonna move it. These extend, and if you push one in, it'll correct and automatically go to the bar. But if you push them both in at the same time, it'll start its climb sequence. Go ahead and push them both in. Okay, there we go. It comes back, and we use what we call a state machine, which it transfers different states based on the position, and then once it meets a certain criteria and it's finished moving, it'll transfer the next state. And once it's done with that state, it'll transfer the next state until it is finally done and on the traversal rung.
Lastly, as we go into anything else from a programming standpoint, I know we talked about that your team can shoot from anywhere. How did you come up with the idea of like shooting from the traversal rung as well, too?
So that started out as a joke during initial start of the season.
Sure.
A lot of people were joking around about it, and then finally, recently, we had enough time, so we're like, we might as well do that. So we got to work, and it wasn't that hard to do because we could shoot anywhere on the field. So we use what we call odometry, which uses all the wheels positions and how far they traveled to get the position on the field. Mm-hmm. So when we go up to climb, we get the X position of the odometry, and we use that to determine where we are on the rung, so we know where the turret or the target is to shoot.
The last thing I'll ask you, since you mentioned odometry on that, is obviously you played an entire match. Odometry, I think one of the downfalls is there can be a lot of drift to odometry as well too. So how does your team compensate for that so you know your positioning at all times?
Yeah, so we have what we call vision correction. So every time we shoot, the camera it knows the turret position, the drive position, the gyro. So we know the angle and we know where the target is because we're aimed, and it'll reset the odometry based on some math calculations.
Well, Stryke Force, like I said, a team that I've been following for a really long time and really love a lot. So appreciate you taking the time to tell us more about your robot. Wish you best of luck here at MSC, and I'm sure we're going to see you at World Championships, so can't wait to see you then. Good luck the rest of the way.
First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.